Hi, we are going to talk about some uses of blockchain with not with identity in the way that you're thinking, and I will let my longtime partner in crime. Actually, we go way back. Let's see, we met first at ARM.
Yep, about 8-10 years ago.
And then you moved into Trustonic.
Yep.
And now you're at a different kind of startup, and you're doing something interesting with blockchain, and we're going to hear about how that interacts with IoT, and let's...
Okay, yeah. So as you say, Andy, I've co-founded a startup to work on some of the interesting challenges of Internet Things and solving them with distributed ledger technology. So the goals for this talk is to walk you through why we set up the startup and convince you that the distributed ledger technology is the right kind of technology to solve these issues. We're going to cover things like identity and IoT, why it matters, who should be involved, and I expect identity practitioners will get involved at some point, the kinds of technologies that will come together to solve the problems, so that we can build levels of assurance in data from Internet Things that mean we can go about our lives and believe that we're doing things right and not being fooled by bots and attacks on our infrastructures. So first off, asking what is identity in Internet Things, I think it was the beginning session, Identity 101, where if you ask what is identity, you get 6 different answers from everybody. Well, you can get a number of different answers from anybody on what is an identity of a thing. It could be all of these or one of these that could count as an identity for a thing. You can all read the slide. What I will say is that these things are static and they're not good enough as identifiers for things throughout their lifetime. Now, I came to this conclusion. I did some consulting for Ping Identity a couple of years ago, and I went through 15 layers of identity technologies, all the way from cloud applications into the depths of a chip within an Internet Thing, and explained all of the different technologies at those layers and what actually constitutes identity. And the surprising result from that survey was, as I asked the questions, after revealing what kind of technologies exist, the surprising answer to me was that a lot of people, CISOs in organizations that are using internet-connected devices, had no idea how these things protected identities within themselves. So whether they used secure elements or physically unclonable functions, software protection methods, trusted environments, they just didn't know. And they didn't know how these things were staying up to date either. So the killer question at the end of that survey was, well, okay, what level of assurance do you place on the data from these things? And 59 out of 100 as a subjective score isn't really that good. So this is one for your social media feeds. This picture illustrates a couple of points. Security marketing hasn't really improved in about 100 years. I took this picture of a lock on a safe in a stately home where there's a research facility. And it just illustrates that security marketing hasn't moved on. Ask yourself, what was version 1 of this inviolable lock? Right, why did it need improving? So I've just sat in a talk about the decay of things Capital One just gave just now, and I have a pithier phrase: things are only secure till they're not. So if things are only secure till they're not, what about the data? Anyone know who this guy is? Yes, Claude Shannon. You were paying attention in class as well. So 24 years ago, I was paying attention. I learned about this guy, and 1948 came up with a mathematical theory of communication. So everything that our IT is built upon, so the theories of cryptography, entropy, channel capacity, data compression, this guy came up with. And the one message that he that stuck in my mind that I thought would come in useful 24 years later after that lecture was, the least expected message carries the most information. Let that sink in. So you get an unexpected message coming into your system from an internet thing. It's either the most useful information you've ever received, or somebody is trying to deceive you and make you do something that you shouldn't. So two of those decisions end up very badly, particularly if your internet things are cyber-physical systems where they could potentially kill somebody. It would be nice to have a bit more information while you're making that decision. So what kind of information could that be? Now, borrowing from social media, what I think we need is something akin to this blue tick of verification. So you see this on Donald Trump's account, and people with large number of followers or people who can move markets, they have gone through extra stages of identity verification to prove that they really own that handle. The financial world has know your customer. We need something for the internet thing world, know your things. Now, if there's one thing that's true, is that identities change over time. Things are only secure till they're not. So there are a number of initiatives in the industry to fix this kind of thing, with the IoT Security Foundation recommending that makers of devices building vulnerability disclosure programs into their services and offerings, and the Industrial Internet Consortium insisting that devices can receive firmware updates. Now, these are all very good. These are guidelines. What we need is something a bit heavier, something with teeth, regulation. Now, there's a 4-letter acronym in the EU that's regulation. And it's not what you're thinking. It's not GDPR. It's NISD. So this is the lesser-known cousin of the GDPR, Network Information Security Directive. And this applies to anybody delivering a critical service that can affect the well-being or the economy of a population. So think electricity suppliers, oil and gas, medical, transportation, airports, railways, road networks, telecommunications. The regulation states that if you're not keeping your things up to date and secured and you're being lax in your security, then fines will be coming. Now, of course, nobody wants to issue these fines because actually we all kind of like to have clean drinking water. We like to be able to get home on public transport after a work day. So these regulations are going to come into force, but they don't actually tell you what to do. They don't tell you how to secure things. Because if they did, they'll just create checkbox compliance. And we all know that checkbox compliance and snapshot security assessments just don't work. Things degrade over time. So looking at industrial internet things and what to do when something degrades over time, who's got to be involved? Now, it's a very, very long supply chain. And this is one of the biggest problems, is supply chain risk. These operators of equipment don't know what's inside their network and what's inside the devices on their network. So let's say a vulnerability gets discovered. The owner who has that bit of kit in their network can't do anything. They have to rely upon the manufacturer of the internet thing. The internet thing manufacturer has to create a firmware update or rotate a key or whatever it may be to fix the thing. It may even be decommission the device and get a new one if it's really bad. So the thing maker has to come up with a fix. And then a technical authority or integrator will then have to assess whether that update is going to break anything else, because quite often somebody pulls an API, and if you've come to rely on that API, well, your whole system falls down. So an integrator will have to sign off on the update. The owner will have to sign off on the risk of applying the update. So they might have to sign off on the risk of not applying the update and applying mitigations around that vulnerability. And then the guy who's actually operating the equipment will have to schedule the update when there's some downtime. or when there's nobody stood next to the device that could die if it goes wrong. And finally, somebody in quality assurance may need to audit that everything has been done. So if you look at this is a supply chain, but it doesn't end. It continues for the lifetime of the device. It's a continuous supply chain. So looking at the kinds of technologies that are available and the kinds of technologies that have been proven to be useful in supply chains, we look at distributed ledgers. Now, distributed ledgers have these nice properties that everybody has visibility of what's on the ledger. So all of those stakeholders in the supply chain can see that something needs to be done. That's half the battle. The poor CISO who's got this kit in his network often doesn't know if the device manufacturer knows there's a problem. With a shared ledger, they know that the device maker knows. They've got the same copy of the data. Distributed ledgers are very good for collaboration across domains, across parties that don't necessarily, or don't have the same network infrastructure. And they're very good at recording history and making it impossible to delete the transactions on the ledger, or for one bad actor to try and change history. So what we see as a startup company is that shared device lifecycle assurance is what we need to secure the Internet of Things and enable this continuous maintenance effort of Internet things with distributed ledgers. So what it looks like is a permanent record, a permanent service history of who did what to what. The who is the thing maker, the system integrator, the owner, the operator, the auditor, possibly a regulator as well. So we need a concept of who. That's identity. That's why we're here. So somebody doing an action to a thing. We also need thing identity and those kinds of identities like certificates that things are very good at managing. Now, with a smart script reading into that ledger, what you can effectively get is a service history, a shared service history of an Internet thing. So just as you go and sell your car on the second-hand market, you've got a full book of stamps in a service record. An Internet thing with a full book of service stamps will have more valuable data. Now, if we can go deep into the value chain and record the attributes of things as they're constructed, as they're deployed, and as they're operated, we get a much more detailed picture of how trustworthy an Internet thing will be. So knowing how a thing can protect its own identity and the identities provided by others is really important. So can it protect a private key, keep it secret, and not reveal that? That's useful information to know. The kinds of technologies that could do that: physically unclonable functions, crypto acceleration units, hardware security enclaves, so secure elements, SIM cards, trusted execution environments. How does it boot up? Does it boot securely? And then we look at the software manifest as well. You know, it may have Linux components in it, and quite often there are vulnerabilities found in Linux. So we'd like to know if there's a CVE issued on a Linux component, where are those devices that have that component? And how do we go about fixing them? And also the operational attributes of, you know, how's this thing being configured? What's its acceptable operational parameters? So why are we here for an identity conference? Well, every actor who plays a role on that value chain that operates a distributed ledger node will need to have an identity system in place, because we need to know who they are. So we need identity technologies to go alongside the shared ledger. We're talking about permissioned shared ledgers here because the participants in the network are known. We know that the CISO will be buying kit from a vendor. We know who the vendor is. We know that the vendor will know where they're buying their components and sourcing their software. So permissioned ledgers here make sense. We don't need a permissionless cryptocurrency type blockchain here, which will give us a verifiable shared history, where if we can cryptographically prove that an internet thing has been well maintained, that will give us an answer to that question of when that anomalous packet of data comes in, that unexpected message. What do we do? Where do we go for more information? We go and check its shared history. And with its shared history, we get a view as to whether that thing is telling us the truth. So what this means is that everybody will be able to collaborate on the maintenance. The CISO's risk of using devices that he has no control over the maintenance and the upkeep can change to a collaborative effort where the risk is shared amongst the supply chain vendors. Everybody as a peer on the network will have accountability, transparency. We'll be able to move from checkbox compliance and certification towards continuous certification and believe the data these things produce. Now, what that means is that for the Internet of Things, we can move potentially to newer business models and sustain the IoT. So here's an example of a connected thing. Imagine a stoplight in a city, and it's smart and connected. How many users could make use of that data from a traffic light? It could be thousands. For an example, it's known that emergency service vehicles can change the lights from red to green so they can rush to an emergency, right? What if you could repurpose that for heavy goods vehicles? Because they pollute the most when they accelerate. So enable the heavy goods users to speed through the city, and it reduces the pollution for everybody. There's some value in that. Or when you're letting those heavy goods vehicles go through, the other drivers are held on a red signal. You know exactly how long they're going to be held. Could you sell that data of how long the red's going to last to an advertiser so they know whether to run the 60-second commercial or the 90-second commercial? Advertisers would pay to know because the higher conversion rate. So lots of potential users, lots of potential value to be exchanged from just one traffic light. All of that enabled with having verifiable shared histories of things. Because if you know that they're well maintained, they're producing truthful data, the data's worth more, people are willing to pay for it if they know it's real. And if that value exchange can then go back to the supply chain that kept the thing up to date, it pays for everybody to maintain the thing, which keeps creating truthful data. You end up with a virtuous circle where Internet things will last longer in service and be secure. And for that kind of thing, we need public ledgers because there'll need to be a value exchange token. So where this all ties in, distributed ledgers, Internet things, machine learning, there'll be such a huge amount of data. We're going to have to use machine learning to sift through all of the information that these Internet of Things sensors create. Having the blockchain and a distributed ledger and that Internet things service history can help with machine learning. So if you've got the strong signal that you're getting data from trusted things, your machine learning will learn patterns that it knows are good rather than patterns that an attacker has fooled it to believe are right. What it ultimately leads to is we have a world where we're making decisions based on assured intelligence. So it means that the Internet of Things can really come to life when you know that you're dealing with real things. So energy trades between households, autonomous vehicles that move aside for people who are willing to pay more and the people who are happier to have a cheaper ride and move aside to let somebody in a rush through. This bright new world of Internet things is enabled when we can trust it. So identity in things, it's not just about certificates. It's not just about key pairs, physically unclonable functions, or tokens, or proof of possession. It's a lot more. It's got to involve dynamically keeping these things up to date and being assured that the thing is well maintained, how it was produced, who's maintaining it, who's collaborating on the updates, where the vulnerabilities lie. And if you want to find out more, there is a white paper on our website and a video of our demo. And the company, Jitsuin. So this time last year, I co-founded it with 3 others. We're now at 11 people. We're based in Cambridge, UK. And there's a story behind the name, Jitsuin. If it looks a little bit Japanese, it is a Japanese word. If you go to Japan and you ask anybody to sign a document, they don't use a pen, they use a stamp. And if it's a high-value document, like a mortgage application, the most trusted stamp they use is the Jitsuin. And what makes it trusted is that you have it hand-carved to yourself by a master craftsman on something like jade, and you take it to your municipal office and you get it stamped. You stamp a record at your municipal office and they stamp it as well, and that becomes the authoritative record of what your Jitsuin looks like. So if anybody disputes a contract, they can go back and check that record. So we're doing the similar sort of thing for things. Jitsu means truth. So for us, Jitsuin is truth in things. As you see from my title, I'm VP Marketing. So softball questions welcomed. If you want to think about next steps, take a step forward and come talk to me. We're looking for proof of concept partners who can take this system into a test and see how this can help improve security postures for critical national infrastructure and services. Thank you very much. Any questions?
I have 2 questions.
Oh, yeah, take the mic so it gets recorded.
So I have 2 questions. The first one is related to the permissioned DLT that you mentioned. Can you talk about difference between choosing that or distributed databases with high level of assurance, which fall under DLTs? And the second question is regarding the public blockchain that you mentioned. What blockchain you're using in particular for the public blockchain part?
Okay, so first of all, we're focused on the permission ledgers, and we're using Hyperledger Sawtooth. The public permissionless system is a roadmap item. So that's something we'll be working on once we fix the issue, which is nearer term, which is getting devices secured for critical infrastructure. That's what we're targeting first.
But is there a reason choosing Hyperledger Sawtooth versus, was there a reason between using Hyperledger Sawtooth versus regular distributed databases?
So there is, yes. Well, part of the problem with a database structure is that somebody is always admin. Somebody has higher rights than everybody else. And that's what causes the problems when things go wrong, the records get modified or deleted and people cover their tracks. With a distributed ledger, everybody's a peer on the network. So that's the reason for choosing a distributed ledger technology. The reason for Hyperledger Sawtooth, our CTO is on the board of Hyperledger. Any other questions?
How much data do you think that one thing would produce in in its entire lifetime, and how it would be justified? The value will be justified for enterprises, in terms of if it's a database and all. I have some idea as to how much of storage is needed and like that. But for blockchain, how do you measure it, and how would we be able to do some sizing around it?
good question. It depends on what kind of information you're going to store about a thing, and how deep into the supply chain you go, and how much risk you're willing to accept by not knowing what's in the device. You can store as much as you like, or as little possible. I don't know, but it's something I'd be happy to explore with you.
Any more questions?
Okay, I think we're out of time as well. Thank you very much.